Have you ever wondered how your favorite beverage gets to the store for you to purchase at a price you can afford? We're taking you on a virtual field trip to see how big data and machine learning can be used to solve real supply chain problems at real companies. This means we'll talk with expert research scientists here at MIT CTL to see how they're using the techniques that you learn in class. And we'll also travel to New York City to work with our industry partners at AB InBev.
Welcome to Anheuser-Busch InBev. Come on in. I'm Michael Kress. I've been with ABI for 3 years now, so I work on our global team on what we call Tier 2 Logistics. So I'm the Director of Tier 2 Logistics Transportation, which means I'm overseeing projects and processes related to taking our beer from the warehouse out to our customer network. So how can we make our drivers more efficient, provide better service, be safer on a day-to-day basis?
So my name is Matthias Winkenbach. I'm a research scientist here at MIT CTL, leading the Megacity Logistics Lab as well as the Computational and Visual Education Lab, which we usually just call the CAVE Lab.
My name is Esteban Mascarino. I'm a graduate research assistant at Megacity Logistics Lab here at CTL. I'm also a graduate student at the Master of Science in Transportation.
If I use Brazil, we have 110 warehouses or so in Brazil. So if I want to look at yearly efficiency at the DC level, 110 data points. If I get down to daily, sounds like a lot, but actually we can manage that. Daily routines, manage that. If I want to look at routes, I've got 1 million. And I want to look at customers, I have 16 million. And I reminded our executives that Excel breaks at 1 million rows. So I can't even use Excel to manage that amount of data, right? And so I have new tools I have to use. I have to use, SQL and databases and Microsoft Azure and Power BI and these tools that we're using in this project that aren't always so native to us, as a company, right? A CPG company. It's new skill sets, new tools. And so just to manage 16 million rows of data, then I want to process it, I want to analyze it. It's a whole new skill set that we need to bring. And I think what's exciting for all the people taking this course is that skill set's in need.
Yeah, this project was interesting because we actually were sitting on a large pile of data that ABI provided us with, first only for Mexico City, later on then also for other cities around the world. Data that they had more or less readily available from their route operations over the course of more than a year.
We have all of this data from Mexico City. If we did this and looked at it this way, maybe we can come up with some insights and look at your data a different way. So it was more of kind of a curiosity, to be honest, an academic curiosity what I could do. And then from us, it was like, okay, it's an outside view of it. So we don't think we came in with what are you going to solve for?
We were given the task to basically just, first of all, explore this data and try to understand what drives the productivity of their delivery routes.
I think if you try to solve something too specific, you're going to struggle. I think you have to kind of be a little open-ended to say, let's pull it together and see what we can find, and then we can start being a little bit more prescriptive on what we're trying to solve for.
In various cities, we're performing on different levels, but they didn't really know why. And that's how we started, by just exploring the data, trying to see whether we find patterns in there, we find factors that could explain those differences in performance.
So essentially the company had a huge amount of data. They wanted to do something useful with the data, and that specifically useful thing was coming up with a systematic approach in order to measure and benchmark productivity across the globe.
So ABI has customers all over the world and logistical teams all over the world who serve the stores that you and I buy their products from. But the company wants to know, why are some of these logistical teams performing differently? Which ones can we compare against one another, and which ones can learn from one another?
So we have 500 warehouses or so around the world. We operate in 30 countries, and we try to compare and say, how do I push one warehouse to be as efficient as another warehouse? So trying to compare a warehouse in Ohio versus New York City versus Mexico City versus Russia is challenging, right? And so we try to use KPIs and things, but it's a little challenging to try to think about how you cluster or compare different realities against each other. And so what we worked a lot with on this project that we'll talk about with MIT is how do you put a little bit more math and methodology behind that comparison set? So how do I, instead of just looking at the overall business and say there's a route in Manhattan that actually looks very similar to a route in Mexico City, same traffic, same infrastructure, same type of products. By using more mathematical models or more variables, I can get deeper into the business and have a more fair comparison set. So that was one of the big things that we did on this project, was trying to be, instead of being at the averages, being much more in the details and being able to try to use those details to compare more fairly and then be able to learn from each other.
In a classroom environment, be it in person or online, we typically do things this way. Your teacher will show you some new technique or concept. You'll get to practice with it by solving problems that the teacher creates. I might set up the questions so that you know precisely what you're looking for and which methods you're supposed to use. But as many of you might know, in practice, you don't always start with knowing the exact question or even knowing the appropriate method. Think back to your lessons on machine learning. What are we doing here? How can we approach this problem? ABI doesn't need to predict anything, not yet anyway. What they need is to organize their data, to probe it to see what it can tell them.
So clustering was one of the main methods that we used because we first of all wanted to basically describe what's going on. We wanted to provide Anheuser-Busch InBev with a metric that they could apply to similar data in any other city that would basically classify their routes in the city of observation based on different performance levels. So we wanted to basically come up with various classes of routes, like the high performers, the low performers, and probably something in between, that would help them understand how the various different routes in the city perform and how they compare to each other.
But I don't know if we had thought through how let's use a clustering methodology to apply to this project. I'm not sure any of us really knew, a clustering would be the solution, right? And I think that's when some of your students can say, oh, I know a technique or a thought way to apply to this problem, right? Like you have a comparison problem, well, it's probably because of, you're not comparing fair things, you can apply some clustering.
So once you've decided that you're going to do a clustering approach, do you just clustering and then you're done?
I wish so, but no. First you get tons of data, hopefully. I mean, if you get data, that's great, because then you can clean it up, which takes 4-5 months.
How big of a burden was data cleaning in this project, was preparing the data for analysis?
Huge, as in every research project and every data science effort, I would guess. Cleaning the data, making sure it's consistent, making sure it's correct, making sure it's complete is a huge effort. Because even though companies sit on a lot of data that they collect every day, they usually don't spend the effort at the point of collection to make sure that the data they collected is actually correct and complete. And then it's sometimes hard to find the right people in an organization who could help you understand the data and validate whether the values that you see in a database, for instance, make sense or not.
If you just input garbage, you'll get garbage from your model. And it's not your model's fault. It's your fault because you didn't do a proper or a thorough data cleaning process. Definitely this particular project had a lot of uncertainties. At the beginning, at every research project, we are completely free to select which are the strategies in which we are going to use in order to tackle the whole project. But in this particular case, I mean, we had a huge amount of data, and we needed to come up with something useful or with a methodology that was scalable for the whole company. It came out naturally from the development of the project that we should at some point segment the routes into their different operational characteristics. So for instance, urban routes with low drop size or urban routes with high drop size, rural routes, low performing routes, high performing routes. So we opted for a categorical classification of the operational environment, and that added an additional complexity to the whole model because we had to deviate from k-means and start mixing both k-means and k-modes. And that's k-prototypes, which is a well-validated clustering methodology, which is kind of, I mean, in layman's terms, it's a hybrid of both k-means and k-prototypes.
So the team cleaned the data, which was a major effort. And then they decided which machine learning algorithm was appropriate to their goals. They started with the technique that we know, k-means clustering, an unsupervised machine learning technique. But when they thought more about the defining characteristics of global beverage delivery, they realized that some of the attributes were categorical. They were things like rural and urban. Taking this into account demanded moving beyond K-means into something a little deeper. They moved into K-prototypes. Did anything surprise you when you looked at the result?
Using the data from 2 consecutive years, we get the same insights from the same clusters, meaning that the methodology we came up with was pretty robust, and that the country was also behaving in a somewhat predictable way. There were no radical changes from one year to the other. So we got like extremely alike clusters with barely the same centroids, the same characteristics, the same operational environment, and the same productivity goals for each of them. So that was kind of surprising for us.
Were there any surprising or unexpected findings to you?
There were still a lot of unexplained differences in route performance that we had some hypotheses on, but that we actually struggled to find the right data to actually describe. For instance, if you think about incentive schemes of drivers and their delivery crews, that's very hard to capture in data. How do you really quantify an incentive scheme for a driver, which is not just how much he gets paid by the hour, but can be a very complex contractual structure, basically.
So a big learning that we've had, probably the biggest learning actually, is the need to be more focused on data and be more of a data-driven logistics operation. So how do I really, think through this data as an asset? Right? So the data itself for us is now becoming an asset through this project. If I can unlock a lot of hidden inefficiencies or find ways to be better at service with the data. So now we have a lot of efforts around the world of making sure we're putting data management, data engineering focus resources together to think about this. I think that's a fundamental shift that we've begun with MIT. We're at the beginning of that journey, but I do think that will be one of the change agents that we use is data as an asset going forward.
Our course is about supply chain technology and systems. Can those things help a business? Yes. We've also covered data analysis. Can that provide new insights? Of course. But let's talk to our experts about how they use those things in practice.
So I'd say now we're still kind of at that corporate level of trying to show people around the world where they might be able to start thinking differently. Cascading that down to a DC manager, that kind of depends. I'd rather cascade something that's actionable for them, say go try this, go try that, than try to present a study that might show that, hey, look, you're not doing as well, this DC is not doing as well, this route's not doing as well as this one. There's no answer for them on how to fix it. I don't necessarily want to create that problem. And so right now we're still kind of in the phase of allowing kind of our more corporate teams that have a little bit more time and are a little bit more forward thinking and have more of that strategic outlook to get on the phone and call different countries, go visit and kind of learn that piece. And then they can kind of harmonize those messages and think through the actions they can put in place. My challenge to colleagues would be, let a data scientist or people who are thinking about your business in a new way take you along that journey. And it's not that you don't know what you're doing or that you don't know your business. It's that there's just somebody looking at it a different way who might find something. And you might find that 90–80% of the things they come up with aren't actionable. But you might find a couple nuggets here or there. You say, oh, wow. And those couple of things can transform your business.
So when we completed this project with Anheuser-Busch, we started this as a small little analysis just for Mexico City. We slowly grew it to other cities, and then they actually partnered up with a professional IT company to implement it in their day-to-day decision-making tool. So they actually went and integrated our analysis into their ERP systems so that you could roll it out easily all over the globe. And that's what makes me a little bit happy because it started as a small analysis here at MIT and is now globally used within ABI.
How do you see the value that the data scientist brings to the practitioner?
And that's kind of the gap that we're trying to bridge, to translate the data science world to for the domain experts to understand, and also vice versa, to make the data science experts understand the real world challenges that the domain experts are facing and that need to be modeled somehow. And that's where I think also education plays a big role, where places like MIT might want to put more effort into educating data translators, so people who have a decent understanding of the domain and its specific real-world problems, and who have a solid quantitative background, a solid education in data science methods, so they can actually talk to the real pure play data scientists and basically be the bridge between both worlds, because both can benefit quite a bit from each other.
Maybe you want to do a project like this yourself, either with your own company or in the company that you might work for in the future. What advice do our experts have for you in executing a project like this one?
So first of all, they should all take a course in statistics and probability. And that's something that's a must. And then they can like step up and go for the more advanced things. But they should start from scratch with simple things: linear regression, clustering methods, classification methods, I don't know, k-means, KNN, hierarchical clustering, analyze a little bit about neural networks, random forests, and that kind of stuff. And they should know which are the advantages and disadvantages of each of the methodologies in order to pre-select them or to have them in their toolbox and to know when to apply each of them or when to mix them. But at some points you might want to step away and do your own implementations. For instance, in this particular project, in order to estimate the number of clusters, or which would be the theoretically optimal number of clusters to use, we ended up using an adaptation of the F statistic for k-means that would also work for k-prototype, and that's not coded anywhere.
And very closely related to that, you need a decent understanding on how to code and how to actually implement these analyses at a large scale. And that means you are not going to get far with standard business intelligence tools like, I don't know, Excel, Tableau. Go one level deeper and try to be able to at least formulate a first version of a code, for instance, in a language like Python. That doesn't mean that you have to be able to code production level software, but you have to have a good understanding on how an implementation of a sophisticated data analysis would actually have to look like. So that you can, if you need a more in-depth analysis and if you need to partner with coding experts, you can actually, again, tell them how you would like the analysis to be structured and you understand how they implement that.
So I think for any of your students, focusing on storytelling or consulting type of skill sets or understanding that journey that you need to take people on, that the answer is the beginning. And so you can do a lot of work to get to a number, and you might be very proud because that got you the A in the class, but that doesn't get you an action or a business accomplishment. And so I think one of the biggest changes that you have going from academia or whatever, it's like grading the test, I got the number right. But getting somebody to actually do something with that number is that all that change management piece. So I would really recommend trying to invest and learning those skill sets and understanding the ways to influence people. And that's the hardest part. I think everyone taking this class is probably gonna be way better than myself and a lot of other people at the math. But they're gonna struggle sometimes to how to convince people. And the ones that are able to do that will be the superstars that are gonna lead the teams. So my greatest advice would probably be focus on that journey and rounding out your skill sets, because it doesn't end with the answer, it kind of starts with the answer.
Matthias, thank you so much for taking the time.
Thanks for having me.
Really appreciate it. Thank you so much, man. This was gold.
It was a pleasure.
Michael, thank you so much for your time.
Of course.
This has been so valuable, and all of your insights will make a big difference for our learners, so thank you.
I wish them all the best of luck.
Hey, thank you.
And send some resumes over to us. We're always looking for talented people here at ABI.
Will do. Thank you so much.
Of course, thank you.
Sometimes the best way to learn a new concept or technique is to see how it's applied in practice. And the only way to see it applied in practice is to go out into the field. Thank you so much for joining us on this virtual field trip. And we hope you join us for the next one too.